Hey guys, today we're going to be talking about this example problem for adding and subtracting polynomials. Well, I guess in this specific example, we're just subtracting. If you want some slightly simpler problem examples, check out the video strictly about this. We go over two problems there that stay within just the realm of traditional trinomials. But I wanted us to take a look at a problem like this because, well, things like this do exist, and sometimes you might be confronted with a problem like this on a homework assignment or something. So let's talk about what happens here. So I have 6x to the fourth plus 5x squared minus 7x plus 2 minus the polynomial 3x to the third minus 4x squared plus 8x minus 16. So our key here is identifying like terms between our first and second halves of this problem to be able to subtract. Because what we're going to be doing is we are going to be taking our like terms here, subtracting them with these. Or I guess I said that technically reversed, but you get the idea of what we're doing. So let's see. To begin, we have 6x to the fourth here. Do we have any terms that go with 6x to the fourth that match those? We don't, right? So are we subtracting anything away from that term if we don't see it, something like it over here? No. That 6x to the fourth is not going to change. So that stays the same for our final answer. Now what we want to look at next is we could look here at 5x squared, but would that be chronologically the next step in our exponents as we step down by degree? It wouldn't. The next one would be x to the third. Now we don't have one of those over here, but we should probably check to see if we have one anywhere in the problem. And guess what? We do. We have this 3x to the third right here. We still need to account for that. And when we are writing our answer, that is what will come next. Now what should we write? Should we just write 3x to the third since there's nothing else to combine it with? Should it be negative 3x to the third? Yeah, that's the one it needs to be. Because even though we don't have any over here, it's kind of like saying 0x to the thirds, because there aren't any, minus 3x to the third. So even though there's not any x to the third term over here, it's kind of like 0. I mean, it is 0. We still need to consider that we are subtracting this 3x to the third. The subtraction sign is going to come in front of any term we have in the second half of the problem. So we're going to write minus 3x to the third here. Next up, let's take a look at our x squared terms. So we have positive 5x squared minus negative 4x squared. I'm going to write that problem out right up here too. So positive 5x squared minus negative 4x squared. So again, this is one of those problems where it's really important that we notice we are subtracting a negative number. We have to make sure we have both of those minus signs in there. What happens when we have two minus signs or two negatives or however you want to word that? Yeah, the two lines combine to form a plus sign. We actually end up adding. So we have 5x squared plus 4x squared. Well, that's going to make positive 9x squared. Next up, we have negative 7x minus 8x. Well, negative 7x minus 8x, that looks like negative 15x to me. And then we can finish up here with 2 minus negative 16. 2 minus negative 16. We have the two minus signs here that will flip or cancel out or however you want to think about that. Again, I just like to use that mnemonic device. So we end up with 2 plus 16 and get 18. And this ultimately becomes our solution to this problem. The simplified version of this very long expression. Now, if you hadn't done the 3x thing as the second step, that's okay. If you just went through all 4 of these terms, subtracted them, and then you looked over here and you were like, wait a minute, I have one term that still doesn't have a pair to it, or a match. Like, you underline all the terms if that's what helps you, and you notice that 3x cubed, it's on its own. That's okay. You could have technically wrote it at the end of this polynomial after you subtracted everything else. You would just want to rewrite it so that it's in its proper place. Again, your answer wouldn't have been technically incorrect if the negative 3x to the third was at the end. It's just more of our quote-unquote proper or standard way of writing polynomials that has them go in descending order by the degree of the exponent. If you have any questions about this problem or would like to see any other problems done, feel free to drop them below in the comments. I'll be more than happy to help out as soon as I can. Otherwise, thanks for watching, guys.